In Group 2, our project topic is New York City taxi trip duration. Here is the content of our presentation. We will introduce the problem statement, challenge of the problem, and we will introduce data pre-processing, feature selection, and the two models we've been used in the project. And we will do the final conclusion for the presentation. So here is a problem statement. The purpose of this project is to analyze and build a model that can predict the total ride duration for the taxi trip in New York City. Here is the details. The dataset is provided by New York City Taxi Commission. This dataset contains a lot of insightful information for each taxi trip as a sample. Then the dataset is containing by training dataset and testing dataset. The training dataset contains almost 1.4 million taxi trips. The test dataset will be used to test the capability of our model. Then the evaluation standard is RMSLE. The target feature is trip duration. Then here is the challenge of the problem. As we mentioned in the previous slides, one of the challenges is that the provided dataset is very large. It's approximately 1.4 million trips for the training dataset. So we need to find a suitable and efficient machine learning model to get the training results. And before we implement a model, we need to do data pre-processing. And we need to find whether there is outliers exist in the provided data set. If it exists, we need to remove it to improve the accuracy. And although there is 11 features in the provided dataset, but not all of them is useful to make the prediction. So it is necessary to select the useful features and also convert them to standard types and create new features before building model and make prediction. And the objective of this problem is to predict trip duration of a taxi trip. So this means it is a regression problem. So suitable regression algorithm need to be selected to make prediction accurate and efficient. So we need to do data pre-processing first. Here we need to find whether there is outliers exist in the provided data set. For example, in the screenshot, we can see that to find the outliers, we need to use the limit values, for example, maximum value, minimum value of a feature, and compared with the mean value range. If the maximum and minimum value is way beyond the mean value range, that means this value is outlier. This needs to be removed. For example, we can see that the passenger counter is cannot be bigger than 6 and less than 0. So if it exists, then we need to remove. Next, we need to check the non-values. To prevent errors, non-values need to be checked. So if these non-values exist, it also needs to remove this specific sample. We can see that in our case, there is no non-value. Then we will do the feature engineering. For feature engineering, we need to find whether there is irrelevant features. If it's irrelevant features, we need to remove it because it's not helpful to do the prediction. For example, the ID, also the vendor ID feature. After that, we need to select the useful features. We need to identify which is the useful features that can derive relevant information from them. And we also can convert them to standard types and create new features before implement the model. For example, from the screenshot, we can see that the ID column is one of the irrelevant features. So we can remove it. So here is our first model we have been used, which is called ridge regression algorithm. So what is ridge regression algorithm? It is a kind of regularized linear regression that includes an L2 penalty. This ridge regression modifies the cost function by using regularization compared with the linear regression. So why we use this ridge regression algorithm? Because the coefficient of the input variables that cannot contribute much on the prediction problem can be shrinked by this algorithm. And the ridge regression prevents overfitting. And how we use the ridge regression algorithm? From the screenshot, we can see that firstly, we import the ridge regression functions and feed the pre-processed data set to the algorithm for training. After that, we will generate the prediction results for the test data set. Next, this one is the second model we have been used. Is a random forest regression algorithm. We can see that the random forest regression algorithm is combined by multiple decision trees for different features and samples. And after get the results for each decision trees, we will get the final result. So from the previous slides, we can have a better understanding of the random forest algorithm. This algorithm joins many decision trees for each features and samples. After get the results from these each features and samples, we will use the averaging to improve predictive accuracy and control the overfitting using these subsamples results. This algorithm is good at analyzing data set with a lot of features. In our case, there is around 11 features in the provided data set. Now, why we use random forest regression algorithm, not others? For example, we can see that the linear regression algorithm only can have an instance represented by one features. It is not suitable for our case because our case have 11 features. And then the 11 features we will use is like pickup time, drop-off time. We can see that in the screenshot. So how to use a random forest regression algorithm? From the screenshot, we can see that we need to import the function first. After import the function, then we will train the algorithm of the data using the pre-processed data set. Then the accuracy score will be calculated by the score function. And after that, the predicted result will be generated by this built-in function and exported to an CSV file for evaluation. So here is the conclusion. As a result, we can compare the score of each module. For the forest regression algorithm, the score is 0.57. It is much better than the ridge regression algorithm. So the forest regression algorithm is better. And we also try to use the unprocessed data to use the model as comparison. After compare, we can know that the result of the unprocessed data is much worse. So this proves that the pre-processing is very necessary and successful. What we have been learned from this project? We learned the process of data analysis by using machine learning algorithm, including the data pre-processing, feature selection, and implement the machine learning algorithm to the training data, and using the test data to evaluate to select the best model. So here is our presentation for this project.